Alright, problem 28. Last, no calculator, multiple choice problem. And look and see if f of x equals secant of 3x, then f prime of pi over 12 equals what? So it's just find a derivative, evaluate a derivative. A whole lot nicer than all that integration garbage we were doing. So I look at this. I have f prime of x, or sorry, f of x equals secant 3x. Let me write that down. Okay, so f of x is equal to the secant of 3x. And I want to take the derivative of this. So I like this notation. I see I have secant and then I have 3x. I have two functions. So I have an outside and I have an inside function. And the way I need to take care of this is I'm going to have to use chain rule. I really love chain rule. It's nice, easy, everything falls into place. But I like using this dx notation. It really sort of shows what's going on. It really helps you see how the links in the chain fit together. So the derivative with respect to x of f of x, I'll rewrite this as f prime of x farther down, is equal to the derivative with respect to x of secant of 3x. And now, the outside function is secant, the first function is secant, so the derivative of secant is secant times tangent. I have this same internal function. I take the derivative of the outside, but I use the inside function in both of them. So I have the secant of 3x multiplied by the tangent of 3x. And then I have that multiplied by the derivative of the inside function. You can see if I use this notation, it's really easy to write. Okay, so now I go ahead and do the next step in the chain. I still have my secant of 3x multiplied by the tangent of 3x. And now the derivative of my inside function, the derivative with respect to x of 3x is 3. And if you get really good at this, you don't even need to write this out. You can just look and see that I have this 3x and I bring it out. Okay, so let me rewrite this. So first thing, let me bring this down and say that the derivative of f of x is f prime of x. That's one of the definitions, or that's how we defined f prime. It's the derivative. Okay, and I always love bringing this 3 out to the front, so we get 3 secant of 3x tangent of 3x. Now I just need to evaluate f prime of pi over 12. So let's bring it in. Let's bring it into the specific x value. So f prime of pi over 12 equals, we still have our 3 multiplied by the secant of 3 pi over 12. Well, 3 over 12 is 1/4. That's pi over 4. Multiplied by the tangent of 3 pi over 12. 3 times pi over 12 is, again, pi over 4. And we all have our unit circles memorized, but just for those that might not have it memorized yet, we have our little unit circle. While it's a lovely circle, pi over 4 we know is right here. Let me go to red. And I know that this is at the point root 2 over 2, root 2 over 2. So, the secant of pi over 4, secant of pi over 4, that's going to be 1 over the cosine. That's 1 divided by this value. So let me say, okay, do this on the side. Secant of pi over 4 will equal 1 divided by root 2 divided by 2. And some of us might know this right off the top of our head, but for those of us that don't, I can multiply the top and the bottom here by 2. That gives me 2 divided by root 2. And there are many ways to see it, but I think the quickest way, you could multiply top and bottom by root 2, rationalize the denominator. It's not actually required on the AP test. They might just require that you know what secant of pi over 4 is, but let's finish this off. So I think the easiest way to see this is to know that, well, 2 is just root 2 squared, and root 2 squared divided by root 2 means that the squared and this can cancel. I'm just left with root 2. So all this work just to find out that secant here, so I have a 3, the secant here is just root 2. 3 times root 2. Tangent of pi over 4. Tangent is sine over cosine. Sine is root 2 over 2. Cosine is root 2 over 2. When you divide them, you get 1. So my answer is 3 root 2, which is answer choice B.